Okay, we know that the probability of A given B will be the probability of A intersection B out of the probability of B. So we start by putting our numbers into that. So the probability of A given B is given to you as 0.4. Probability of B is given as 0.5. Okay, and this equals what we're looking for, A intersection B. So you're simply going to do 0.4 times 0.5, which is 0.2, and you've got your first answer. So from the previous question, we've worked out that the intersection is 0.2. We know that probability of being in A is 0.4. That's given to us. Okay, it's given to us there. So we use that and make that 0.2. And the probability of being in B is 0.5, so that makes that 0.3. So not being in A and B would be 0.3 because all probabilities come to 1. So for part B, what's the probability that we're not in A and we're in B? Well, not in A and also being in B are these two. So the answer for that is 0.6. Okay, so part B, let's put that there, B equals 0.6. And the last question, in fact I've actually covered up the previous question. What they're actually asking is not being in A and not being in B, so we'll quickly change that. Not being in A and not being in B would be 0.3, which I'd already put into the diagram. And the last part, not being in A but being in B, is where you can see the ticks, so our answer is 0.6. So in this question, we've been given the probability of A as a quarter, probability of B as a half, and probability of A or B is 3/5. So we'll start off with the rule, which we call the AND rule. So the probability of, get the pen to work. Right, we've got the pen working now. So we start off with our AND rule. So we've got the probability of A or B equals probability of A plus the probability of B minus the probability of A and B. So dropping in the numbers we've been given, quarter and a half, so 3/5 equals a quarter plus a half minus the overlap. I'll just call that x for the moment. So a simple bit of calculation. So we've got 3/5 is 0.6, 0.6 equals 0.25 plus a half is 0.75 minus x. So our x is going to be 0.15. So I've put the information from the previous part into the centre. We now know that A intersection B is 0.15. So if A is 0.25, we must have 0.1 there. And if B is a half, we must have 0.35 there. So the whole lot comes to 0.6, leaves me 0.4 on the outside of the circles. So this really will make the answering the next two questions fairly straightforward. The probability of not being in A and being in B at the same time, just change the colour here, over. So not being in A is there and there. Okay, so we're not in A and we're in B would be 0.35. Okay, so that's 0.35 for B. So and C. So just to recap the previous part, if you're not in A, you could be in 0.35 or 0.4, but it wants to be in B as well as not in A, so it is the part here. So on to C, not in A and not in B is the 0.4, so we'll just colour that in green so you can see where that is. Okay, so that's what we're looking for. And that's that question done. Now, it's a slightly tricky one this, but if you take the probability of C given D, probability of C with D not occurring, then if you add those together, you have got the probability of C. So the probability of C is going to equal 1/3 plus 1/5. And I'll show you that with a diagram in case you're not clear. So we've got C and we've got D. So we've got the probability of C, given that D has occurred. Okay, that puts us there. And then we've got the probability of C, given that D hasn't occurred. Okay, and so that's going to be that bit there. And the two together give you the probability of C. Now a third and a fifth, I'll do a quick bit of cross multiplying here, and we're looking at 8/15 for that. Okay, now that doesn't answer any of the questions yet. What it actually does, it actually answers part C, because we're asked for the probability of C there. But I like the fact that I've got the 8/15 for C. So I can put 8/15 there, and I'll use that in the later part of the question. Now, right.